From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Coming from a chemistry group, your first instinct is, I can design this molecule better in my head, put it in, and have everything to come together. And you might be able to, and it very well might be the best material out there. But as soon as you do that, as soon as you have to get your own factory to build that up and put everything else, the capital you need, the cost of those materials doesn't often become worth it when you get to, for a high-end, low-volume part, can be worth it, but for high-volume parts, it's just not there.
That was James Hedrick. James is currently the Chief Product Officer and co-founder of Azul 3D, which is commercializing the first 3D printing technology capable of competing with the speed, strength, and economy of scale of injection molding. James started his first company at the age of 16. The profits paid for his college tuition at MIT, where he was also at NCAA a student athlete. He went on to receive his PhD at Northwestern University with Professor Mirkin, during which he developed seminal technology at the core of Azul 3D. He was both a National Defense Science and Engineering graduate and Ryan Fellow. Dr. Hedrick has authored 16 manuscripts and has 5 patents. He was also named to Forbes 30 Under 30 class of 2020. Excited to have another fellow Chicagoan on the podcast this week. So I like to start these episodes with some contextualization of each of the guests. So tell me a little bit more about a young James. Where'd you grow up? Where'd you get your start in engineering and even manufacturing?
Awesome. Well, first, Mike, thanks for having me on. Starting with my background, I grew up in the Bay Area in California. So young James was very much out doing lots of person that liked to take the stereo, take it apart, and not quite figure out how to put it back together. Would be a good summary of my childhood. Did a lot of different creative problem solving organizations back then, and then first found engineering passion once I got into college. I had seen that's when I first got the hint of it, and kind of got the bug from there and never stopped.
So did you, in high school, were you thinking of doing engineering? Was that the track you were going down, or what was the
I knew in high school, I liked math and I liked science. And so I knew I wanted to do something along those lines. And that's what I was kind of I loved chemistry. I also loved math, but there was no engineering courses in high school before. So I didn't quite put together that it was combining those that ended up being chemical engineering that I ended up doing in college.
Got it. And so what specifically drew you to chemical engineering? Was it the idea of working in a big chemical plant and making sure that you're the one that understands where all the pipes go and the valves go on and off? That's my stereotypical assumption of what chemical engineers do.
And that is probably the most common thing that chemical engineers do, but I didn't actually know that's what chemical engineers did when I started as a chemical engineering major. I thought it was you were a chemist that also built the machines around to do more chemistry. When I got into my first Chemie 101 class, I realized that, oh no, this is not chemistry at all. They use molecule A plus molecule B goes to C, and that's the level of chemistry they ever care about. They never care about what the actual things are, but it was what really drew me to it was someone told me, the exciting part about chemical engineers is how multidisciplinary it comes into, and the problems you can, so the coursework can be really challenging and really exciting because of this combination coming together more than me ever actually thinking about what I wanted to do with my career after.
And so what was the sorry,
don't die on me here.
I'll edit that out. But what was the, as you're starting your kind of college path, were you looking to get into industry, staying in the academic side? Where were you kind of leaning early on?
Early on, I had no clue. And I would say even late in my bachelor's, I tried a lot of different internships. And I think this is one of the things that I got really lucky was I was doing research projects, starting my first semester in undergrad. I worked for a professor for 3 years there. And then every summer I was going to do a different project. And each one of the projects I did was in a completely different field in this like broader physical science field. So I did stuff like flexible electronics, did stem cell research at one point, did drug delivery. I was designing new molecule or polymers at one point as well. I kept just jumping around trying to figure out what I wanted to do. I would say even at my end of my undergrad, I still had no clue what I wanted to do. So I was like, I'm not ready to make a decision. I'll go do my PhD. It seems like I can pause this real life thing and just keep in school longer to try to figure it out.
And how did you decide on kind of what specifically to study in your graduate program?
To be honest, it kind of found me more than me finding it. So I applied to a couple different schools. Northwestern seemed like a pretty good school for me because I grew up in California. I always thought, you know what? I want to go as far away as possible for undergrad. So I went out to Boston and I was like, I should see the rest of the country. So Chicago's halfway home. And then when I graduate, I can make it all the way back to California and say I've seen it all. Of course, it didn't quite work out that way. But so started at Northwestern there. And when I was picking lab groups, it was the people more than the project that got me into the lab group I was. So I started working for Professor Mirkin. He had one of his groups, which is the dip pen nanolithography group, had some of the most brilliant chemists in it that actually the two people that I worked with first are now their own big time professors at Virginia Tech and Boston University. And it was just a phenomenal discussions and conversation going on that it just got me hooked. I didn't even really care about the project. I just cared about how we were thinking about the projects and how we were trying to push boundaries at the problems they were trying to solve.
And what did you specifically study or like not study, but like what was your research focused on?
So the core of my research was around nanolithography, which just means nanoscale patterning. It was 2D concepts. It first started with actually patterning proteins on surfaces to see how stem cells would be able to differentiate and be affected by different patterns and different proteins. And then I quickly jumped to a different technology one day when they were just like, here, you're doing this one when we got a new grant, which was heterogeneous catalysis. So it was the same concept of patterning, but now we were patterning nanoparticles. And we actually had a pretty amazing paper out there. And a whole company has actually gone into this in its own right in the field of catalyst discovery, where you could pattern these multi-metallic nanoparticles that have up to, I think they're now at like 10 or 11 components. It's kind of crazy how many metals they've been able to come together into millions of combinations of once onto a surface. And so we were just looking at fundamental chemistry of how this all happens. And then halfway through my PhD, we finally got the grant that I had always wanted to do, which was nano 3D printing. And it was the one I was able to help write my first year. And because, I saw some 3D printing stuff, I kind of got hooked like everyone else on it, but also had my track of the nano. So we were trying to start building the world's smallest 3D printer. And so that's where the last half of my PhD went into, was the nano printer, and then eventually into what we call the HARP technology, which is what eventually became Azul.
And do you remember where your first interaction with 3D printing was?
My first interaction with 3D printing was I remember being in undergrad at MIT when Form Labs did their Kickstarter and seeing that. I thought it was the coolest thing ever, but I couldn't find a printer anywhere nearby to actually use. Probably wasn't looking hard enough now that looking back at it now. My first year of grad school, we had a desktop FDM printer. It was one of the ones that had the 3-axis or 3 pillars that went up and would go off of it. I can't remember the name of the brand at this point in time, but I remember we were trying to print lab parts with it. End up mostly getting printed like the low poly Pokemon things were all around the offices of the grad students at the end of the day. But it was that was my first real exposure to using a 3D printer.
So talk about the transition to Azul. Kind of what led you there? Was it directly after grad school? Were you starting it during kind of as you were doing your research? Like what happened there?
It was 6 months into building that nano 3D printer. So the goal at that point was to try to build the world's smallest 3D printer. We had this technology that could do sub 100 nanometer resolution using standard 405 wavelength light, which was something unique and special over about a centimeter area of shining light at once. And so as we were developing that technology, one of the big issues we had was, just like everyone in 3D printing on the macro scale, the adhesion. The resin would stick to our interface and rip it off. And on the nanoscale, it would completely rip this array apart pretty quickly. And so we were trying to develop new interfaces to protect it. And that's when we started using fluorinated oils. And it would start helping a little bit, but what was the real magic was that this array was a scanning system that when we had it moving while the light shined and the oil protecting it, that combination worked, and it would actually allow us to do nano printing in a continuous format. And then that's when we kind of had this aha moment of, we also, I would say within a couple months of that, had Carbon came out with their super fast printer. Jody Simone came to our university, gave this amazing talk, and we saw there's a lot of amazing things here in continuous 3D printing on the macro scale. This is a real industry changing time period right now, that there's the time for 3D printing. And then we realized that there's still this gap in 3D printing where there's these large, SLA printers are huge and they can do these large, gigantic areas. And then you have these new continuous systems coming out that are incredibly fast, but they don't have that area. So could you find a technology that could go between that two gap of SLA size with these new continuous DLP printer speeds? And that's what we thought, this interface we developed on the nanoscale, you ripped out $100,000 worth of optics, put an off-the-shelf projector underneath this layer of oil that's flowing, and you could actually do both. You could have the same speeds as the continuous printer with this new mechanism, but because it's a liquid could be poured in whatever size vat you want. So you no longer have this membrane bowing issue, but now you could just, there's aquariums that are, literally the size of a football field out there. Could you just have something like that and do it? So halfway through my PhD, we did this experiment, it worked. And so we started Azul shortly thereafter around it. And I actually, for the first couple of years of Azul, was still a grad student as we're getting it off the ground.
That's awesome. And so I've not really talked to anyone about this specifically, but it's starting a company within kind of the confines of a university has some hurdles or some advantages, right? So you've got the equipment, the know-how, the reputation, but what's the process to start a company? Like, I'm assuming there's IP issues and different aspects of maybe the legal side that are not always straightforward.
Yeah, university is a little bit different. In some ways it's a lot worse. In some ways it's a lot better. So one of the nice things with the university, of course, the funding that came to do all the R&D, we had grant money allowed us to do this, but you're right. As soon as you develop something on a university grant, the university owns the IP. One of the great things with Northwestern, and I cannot give a big enough shout out to them enough, is that they have a responsibility as a university to commercialize technology that gets patented. And the best way that they see commercialization is if a startup wants, the professor and the grad students that are part of that want to create a startup around it, they're the ones that they're going to be giving that IP to. And so our original set of IP was filed through Northwestern. We knew at the time that this was exciting enough that we were going to be doing it as a startup. So Northwestern made sure they got the best lawyers that they could find for this area to be able to set it up right and then exclusively license it to us. I will say there's a lot of red tape and a lot of time that takes to actually do that. So it's easier said than done, but they did actually give us a ton of support. They actually were one of our first set of investors. Northwestern helped they had a startup fund that we were able to apply to and get capital there to help us get off the ground. They helped rent us space at the start as well to be able to have a facility and area, because having chemical grade lab space is not a cheap thing and not an easy thing, especially if we're both in Chicago. Chicago is a really hard place for that to come by compared to some of the coasts that have more startups that have happened and turnover, that there's these spaces that you can find. And so without them, we probably wouldn't have been able to build up this company here in Chicago the way we have, which we found incredibly important. Chicago is the right place for Azul.
So talk about the early team, like who was involved and kind of what were some of the early goals of spinning the IP out of the university?
Yeah, so the original team, there's 3 founders. There was a postdoc in the lab, David Walker, as well as our chairman of our board now, and our third co-founder was my PI in grad school, Chad Mirkin. So that was the initial team. We shortly thereafter started getting a couple of good undergrads from Northwestern that were graduating. We were lucky enough to work with a couple of them in their senior design class. So that was another way Northwestern helped us out, is they put this project as the capstone project for the mechanical engineering hardware team. And we had probably 15 engineers, seniors, that were working on a couple of the different key areas, helping us build this up, helping us figure things out and start growing from there. And then we quickly started recruiting across the country for some really great engineers in really 4 key disciplines for us. So we started as a hardware, started building that out. Then what we realized really early on is that for us, hardware was the starting point of the company, but materials was going to be the real value. That at the end of the day, it's almost garbage in, garbage out of what goes on these printers. If you didn't have materials that were designed for a continuous print mechanism going at the speeds we're going at, it wasn't going to work. You couldn't take an off-the-shelf printer that was doing traditional layer by layer DLP and get it to and modify it to work. You had to start from scratch almost. And so we had to start hiring chemists in that field. Then we started learning quickly, like everyone in the field, we were only going after manufacturing from the beginning. That was the vision. That was the goal that the team had set. Software gives you that reproducibility. You're doing automated chemistry on this printer. There's so many variables that are coming in that you have to be able to monitor and tune and keep consistent. And that came from software. And the final area, which has always been my favorite part of it, is the customer side of it, which is our application team. And so we started recruiting in that area as well, as someone who would run the printer, and not just run the printer, but also rethink how all the processes came together, be that point person between all these different groups, and also tune geometry for the printer. So design for additive, I'm sure we've all heard it a million times how important it is, but it is something that every time you have and this is the hardest thing I find with it, is that there's a base design for additive that you can do as a user, as a potential customer of ours. And it's great knowledge and bases, but every single printer is going to have these fine nuances and differences that you really have to understand. And that's where we had to learn what ours were to be able to start translating that to customers.
And going back to the material side, can you talk a little bit about some of those considerations that you had going in, knowing that, hey, we're going to focus on manufacturing, which means bigger, eventually kind of bigger supplies of the materials that you're developing, but then also like there's a lot of different potential manufacturing applications. One of the things that you and I have talked about is like, we want to have a wide material suite, or the potential to at least deliver that. So there's this, you're trying to aim for kind of both depth of, can we make a lot of this that's consistent, that works in our process effectively and consistently, versus like, we want a lot of different options. So what are the challenges involved from a material standpoint as you've been building out the company?
Yeah, there's so many challenges when you think about it, and COVID has only made it more complex with the new supply chain out there. But this is where I think we got really lucky with one of our first hires. Our director of materials here is Richard Smith, and he comes from an industrial background. And it was one of these perfect stars aligned, and timing came in that he has done some of the most amazing like things that have been tons of material sold per year for 20 years of these formulations that you'll find in like your cars every day on the side of windshields from some of his adhesive stickers and stuff like that. That the concept was, okay, we started as an academic background, but we're going towards industrial applications. Can we do an industrial approach to chemistry? Can we look at other industries, not 3D printing, but can we look at paints, adhesives, even nail polish? Think about how they scale things up. Think how they make formulation work. And there's some really great materials there. Can we apply that set to 3D printing? And that was a big thing for us, is that anything that we're looking at for going into our materials, we always care about what is the supply chain today? Is it that are we going to be using less than a fraction of a percent of their supply chain? So that it's a very big statement, because 3D printing is still minor compared to any of those other industries that I just mentioned a moment ago. Also, the cost point. What happens as we scale up on it? Where is the economy? Is the economy of scale already in place with these, which is one of the goals with having that big supply chain and setup already, so that we know as 3D printing scales up, as we go to the next step of manufacturing, one of the biggest issues is not just can you get enough material, but can you get enough material at a price point that makes sense for competing against injection molded parts? And so that had really become the core of our philosophy, and still is today, of designing formulations around the material supply chain that you have, that is at a price point that you care about, quality control that you can trust, and at the volumes that you're not worried about, them having to make custom batches at a certain size for just you.
For sure. And that's just tricky for everyone across the board as well.
Yeah. It's one of those balances that I find that, and this is the hard, like coming from a chemistry group, your first instinct is, I can design this molecule better in my head, put it in, and have everything to come together. And you might be able to, and it very well might be the best material out there. But as soon as you do that, as soon as you have to get your own factory to build that up and put everything else, the capital you need, the cost of those materials doesn't often become worth it when you get to, for a high-end, low-volume part, can be worth it, but for high-volume parts, it's just not there.
And so how does that thinking, or kind of that set of constraints, maybe is a better term, influence some of those early customer conversations, right? Like as a startup, like you're trying to get anyone to pay attention, and then anyone to say like, hey, this could be a good fit, even if it's like may not be the perfect fit, but it's good enough. But like as you've refined that, and as you've kind of maybe narrowed down your design for additive, what the machine's good at, kind of your material kind of sweet spot with kind of the current portfolio of options available. Like, how did that really develop? Like, I always love these, like you got to start somewhere, right? With these, and the business plan kind of goes out the window eventually, right? Of what you thought initially would be a starting point, right?
Our business model has changed a dozen times since I started. We feel really good, and it refined in each time to something that was more. As we started developing up, we realized that because originally it was all about the printer, and it was all about printer sales. And now we've gone to the other end of the spectrum, where one day I wish I can give these printers away for free. And it's about the materials and going towards that. But the pitch and this is how we got companies like Wilson and like DuPont to really be working closely with us. DuPont is one of the largest chemical companies in the world. They know chemistry better than anyone. I'm not going to pretend to have anywhere near the firepower that they do on that side. But what we offer as a 3D printing company that has been different is, because we're able to go from these big supply chains, we can quickly tune our materials. And because we're going after manufacturing, so the minimum amount of material any one of our customers would commit to with a custom material now is a 1 ton of material, metric ton of material per year for a single printer. And at that size, you can actually customize the materials. And that's always been our philosophy and vision and pitch, is that injection molding you have 50 different variations of material out there for just one. If you say ABS, they'll give you 50 variations on it. It'll be, glass filled, grade 1, grade 2. There's so many different variations. But if you go to traditional 3D printing companies, they'll have their durable material, they'll have their rigid material. There isn't a variation with that. And so our philosophy and mindset was, because we don't have to synthesize every single component and scale it up, and we can be sourcing different components on the fly, could we actually give you a custom material? Could we actually tune both the material and the geometry together to get that perfect part? And we found that there's a lot of applications out there that were lacking that ability to tune the materials with the geometry. And that's when we really started finding footing in these bigger applications and these bigger customers from that.
And what's your experience been now? I mean, the 3D printing is not necessarily new. It's been around for 40 years. Like, even the conversation about production been around at least 7 to 10 years. Like, is there, when you come out with a new machine, a new technology, new platform, new materials, what's generally the reception? Like, is it still a lot of people that haven't seen any printers, or like, are you getting like really like tuned in questions like, hey, Carbon can do this, and 3D Systems can do this, Formlabs can do this? Like, how granular have you gotten in terms of like distinguishing yourself from the competition, not just in liquid resin, but powders as well? Like, the challenge, it seems these days, is there's so many options, especially as a user per se. Like, where do you even start? Right.
Yeah, it's interesting because it's been a long time since I've talked to a customer that hasn't touched 3D printing or know about it at this point in time. And it's, when did they last touch it completely defines the conversation. I remember going into some big injection molding companies as my first customer visits, and they used printers back in the 2000s. And they're like, yeah, we were going to use it for production, and it just felt like the materials were too brittle, it was bad. And they still had a bad taste for buying a couple $100,000 machine, and it just not working at all. Right, the technology wasn't ready then. And I think the amazing thing is there has been such a growth in technology in the past decade. Production talks have been around for a long time. Additive vision has always been to go into production for 40 years. But material first, it was the interfaces. The printers couldn't print fast enough. Then it was the materials weren't good enough. And then there's everything else, from the automation, the supply chain wasn't ready. I think we're finally getting to that point. But you're right. A lot of the customers we hit today, that they ask us right off the bat, how are you different than the other liquid resin companies? And they usually have 4 or 5 names that they'll shout out real quickly of, yeah, why are you different than every single one of these? And then why are you different than, the powder beds, the HPs, the EOSs out there that have been their more reliable ones? Because liquid resin it's a risk in a lot of ways, because if you don't do, liquid resin has the potential to have the biggest library of materials. Like, we have 450 materials back of house today that are starting points. And then I'm on top of that saying I will customize in beyond that to what you need, because we have so many varied possibilities that we can put into a single formulation that you just cannot do with a powder-based system. But on the other end of the spectrum, that also means that there are so many quality control risks that you're worried about. And it's both from the actual processing of it to the actual mixing of the resin and all these other components. But to us, it has been 2 buckets, I think. Now, jumping a little bit further into the customers are the ones that they're looking for one very specific thing, and no one's been able to meet it because they have this grand vision for 3D printing. And that's when we are able to dive in with these custom materials. And then the second set of people are the ones that are really just at today having something where it can be done with 3D printing, but they just want the economics better. And that's where the size and the speed come in. And the conversations are completely different, because it's really what you're caring about is either economics or technical. And we're finding that those are the 2 areas that I find customers to be in those 2 camps right now.
How is your role evolved over the life of the company?
Yeah, my role has jumped around an incredible amount, and it's been fun for it. So I started as one of the inventors of the technology, heavy on the tech side, and then as we started building up, I had to trust my co-founders and my team to be able to start keeping the tech going, and then my role really turned into the fundraising side. It needed, startups. The hardest thing in it is to make sure the lights stay on while you and give you enough time to build out this product that you originally invented so that you can get it in the customer's hands. And so that's where my role for a really like an 18-month stint was around. It was really the getting the first round of funding and the second round of funding. And honestly, that part of my role will never disappear and is still now. But as we were starting to get that second round of funding, it shifted more into the customer side too and starting to solve it. Because what we found with it is it's not, at our stage of company, it wasn't just having a good salesman that can give you a pitch. It was what our customers actually wanted was someone that would work with them and help solve the problem. And the problem is how to make this idea in their head a reality. And so it was how to utilize our printer in the best way possible. Now what I'm moving my role into today is this combination mix of still on the sales side, but it's now my title is Chief Product Officer. And the concept here is to be able to both help make each level of our product fully finalized and user functionality. But the other step, the real fun, the joy part now is that we've made chemistry and applications all customer centric. We aren't just developing chemistry. At the early days, we had to develop chemistries in every which direction just to get a good basis. But we have a large enough library of elastomers, the rigid, the durable materials that we're really just only focusing on the applications that our customers bring and using our chemistry knowledge to focus in and tune that with the applications team tuning in the geometry together and seeing that working hand in hand to get good projects out the door so that when a customer gets one of our printers, they also have a functional part that they know they could run on our printer day in, day out.
Sure. And so, I mean, at this point, you've probably talked to hundreds, if not thousands, of prospective customers. Do you get better at that? Do you get are you able to better predict kind of, hey, I have a feeling that kind of what you guys are saying in terms of your needs is a good fit for us, or even the personalities, right? Oftentimes it depends on who's in the room when you're first talking to people. How is that? Are you able to kind of do some better prediction on that? That's always something I'm curious about, is especially engineers kind of going into the sales and doing the pitching of new technology.
I think I've gotten a little bit better on the sales side of talking. I'm naturally one of the biggest introverts ever, and I hate talking all day. Talking for me drains me like nothing else. I could be at a whiteboard all day and I'll be at home and can work all night. Do 3 big pitches in a day and I'm done. After 3 hours of meeting. But one of the things that has been really helpful for us is honing in on the questions. It's what do you ask? What do you get out of them? Make sure you're getting the right set of data from them. Because at the end of the day, it's for us, we are not, again, trying to just sell printers for the sake of selling printers. If we were, that is much more of a true, good salesman getting out. I don't ever want to feel like the used car salesman where I'm just trying to push something onto you and we'll find out if it works. Our whole point of having a gated sales structure is that we go through a set of questions with our customers and find out, do we hit your needs or not? And I think that level of honesty has made it a lot easier for customers to trust us, because we'll tell them, no, we can't do what you want to do today. But then we can come back in 6 months and we have this level of credibility because we now have this new part of technology that hits the new requirement you had. Is this still an issue for you? And if it is, we've been able to get these conversations restarted in a really good way and move really fast at that point, because they knew if we were willing to not waste their time the first time, that we were waiting till we actually had something and it was worth them checking out.
For sure. So can you talk a little bit about kind of where the printer is, where kind of the development is of the printer, kind of what's commercially released, kind of what the the status is of kind of the development?
Yeah, so we just announced our first generation printer, which is the lake printer, as we're calling it. We're doing bodies of water and that blue color because Azul, that's a nice theme that we thought we're going. So our first printer was called the Pond. It was a little 6x10 inch. This new one is a 10x12 inch printer. And we also had a large prototype that was over 2 feet in size. And so with that, this printer we just announced back at Rapid, so in September of last year. And so we've started taking deposits now, and we're still taking deposits now for that printer for deliveries at the end of this year. And so we're really excited to be starting getting these printers out the door. We have some beta users that have been using it with great success so far. And right now it's all about just getting that one ramped up for production. And we're really, the customers that are starting to take these printers and getting the deposits in are for people that are truly looking for a production printer. We're not just getting a printer that they're going to be doing R&D for the next couple of years on, but really when they get that printer, our expectation and their expectation is to start hitting the ground running with a manufacturing production.
I imagine too, like if someone's interested in the printer and learning about the technology and trying materials, you guys would also make parts for them or kind of help kind of hone in on specific applications or do some refining of geometries collaboratively with them to see if it's a good fit.
Yes. So yeah, it's one thing, and this is part of the gated sales process that we set up that has made it kind of a lot more streamlined with us. We do a small fee for doing a benchmark just to make sure there's some level of seriousness of engaging, because the most valuable thing we actually have time right now is time. We only have so many application engineers, so many people that we can be working with compared to the people coming in. But as soon as there's a project that, both sides see high probability, high setup for success, we dive full in. It's one of the things too. We're not trying to sell 1,000 printers over this next year. We are looking for people that want to really partner with us, get that level of engagement where we can do that customization, both on the material and the geometry with their design team. So we don't want to take your design fully and just redo it and say, here's the best thing. We want to work with you and give you that level of hands-on that you're looking for, because every company is slightly different, and then really take that to a full partnership as we move forward.
I like to wrap up all these conversations with kind of some reflection on your own career and kind of for those who are kind of maybe just starting either their career in industrial additive or maybe college career. What advice, kind of upon reflection of where you've come from and kind of all the different opportunities and the startup experience so far, kind of what advice might you share in terms of someone kind of looking to see if 3D printing is an industry that they want to kind of join or take part in?
There's two things. One, start trying to see your path. You got to go test the waters out, right? My first lab experience, going back to there, we had that little desktop printer that got me hooked, which was awesome. But the other thing, when you're starting to look at additive, entrepreneurship, any of these things, it's going out on a limb. The biggest thing is finding the right people to do it with. You need that team with it. Doing everything on your own is too much of a burden. Now, like I was saying before, I had to step over and help raise the funds. Well, our R&D team really stepped up and was able to keep that technology going. You need to find that group of people that make sure that you're having a fun work environment, but you're excited and you're motivated to keep moving forward. And that's the biggest thing. That's what got me into the lab that ended up making Azul happen. It's what made Azul keep going, made it something that it's just a fun career path to go right now, is the people that it's with, as much as the journey and the motivation that has made Azul keep going forward.
Awesome. Well, James, thank you so much for joining the show today. Excited to see where you guys continue to take the technology, and I'll see you around Chicago.
Sounds great. Thanks, Mike, for having us on, or having me on today.